Hello there, and welcome to video number 212. This video is on cumulative frequency. The keywords I've got for you are cumulative, frequency, median, upper quartile, lower quartile, and interquartile range. That's what UQ, LQ, and IQR stand for. So cumulative is adding up as you go along. Frequency is how much of something there is. The median is the middle value of an ordered list of numbers. The upper quartile is 3/4 of the way through that list of numbers or set of data. Lower quartile is 1/4 of the way through, and the interquartile range is the difference between the upper and lower quartiles. So cumulative frequency graphs are used to represent data, information. This is how we are going to draw them or interpret them. So to draw them, we add up the data in the frequency column as you go along to get the cumulative frequency, the added up amount of stuff. Plot the highest value in the class width with the cumulative frequency, whatever that might be. Join the points with a smooth curve. Then to find the median value, what we do is we go halfway on the side, so the y-axis, drawing a line that hits the curve that you would have drawn in the graph, and then draw a straight line that goes down to find the median value. You do the same thing for the upper quartile and lower quartile values respectively, but go from 1/4 of the way and 3/4 of the way up on the y-axis scale. Now to find the interquartile range, you do that by finding the upper quartile and then taking away the lower quartile value. Okay, now the interquartile range is the middle 50% of the data that's been collected, and it's a more accurate measure of the spread of the data. It kind of gets rid of any low end or high end outliers. So it's a good measure of spread of data and consistency. So in question number 1, we've got to draw a cumulative frequency graph for this following data. It's about days off and the amount of people that have had that number of days off, or between those numbers of days off. So it's group data again. So between 0 and 2 days, including 2, not including 0 days off. Maybe it could be. Then we've got 2 to 4 days off. 2 not included, 4 is included, right? Because 2 was included in the previous group. You can see that 18 people have between 0 and 2, 6 people have between 2 and 4. All we've got to do to get our cumulative frequency, it's really simple, is add them up as we go along. So 18, can't add it with anything else, so let's just start with 18. Then we add 6 to get 24, then we add 11 to get 35, and then 4 to get 39, and then add 3 on to get 42. So we can see that the top end of our cumulative frequency is 42 people or things that are being represented. Okay, so what I'm going to do is I'm going to zoom in to the graph so you can see more accurately what is going on, and I'm going to plot some points, and hopefully I'm not too far over the graph here. Now I can see that the top end of the class width, or the first class width, is 2. I'm going to plot that at 18 on the cumulative frequency scale, so that goes around there. Then I'm going to go to 4 because that's the next one in the next highest class width there, so 4 at 24, so plot that up there. Then I'm going to go 6 at 35, then I'm going to go 8 at 39. This says 4 on here, that's a mistake, that should say 8. Alright, so 8 goes up to 39, and then you'll see that 10, it needs to be plotted at 42, so we just go past there like that, right? And what we do with this is you can start at the bottom here and you can join it up to the first one. 0, 0 can be plotted, right? Or we could start here, okay, and we try and draw a nice smooth curve. Now that is quite difficult to do on here, I think, so I'm going to try it, but probably won't work out very well. That's not too bad. All right, so we go like that. There we go, nice smoothish curve drawn, and I might be able to zoom out and that might stay there. There we go. So that is all you had to do for that first question. Draw the cumulative frequency graph. Done it, found the cumulative frequencies, added it up as we went along, plotted the points at the right places at the top ends, and that was that. Alright, so I will get rid of that one because I need to get rid of this tool to go back to the other thing I was using. And there we go. And I can just show you that that's not supposed to be that's supposed to be an 8 there. All right, please ignore that mistake. Now, question number 2, estimate the median number of days off. So this relates to the graph that we just drew over here, but I've pre-drawn it, and again, as smooth as I possibly could on the computer. Anyway, And to estimate the median, I will zoom in again, actually. So maybe I didn't need to do zooming and the erasing, but let's just have a little zoom into this one. And I'm going to get the line tool up because I want to draw a line, and I want to draw it halfway. Now halfway, half of 42 is 21. So I'm going to draw from 21 all the way across and hit my line, and then I'm going to draw a line going down. And you can see that that is halfway between 2 and 4, which is 3. So estimating the median number of days off is 3. And I'll write that horribly with this horrible tool that doesn't like writing on this computer for some reason. That is supposed to be the number 3. Let's see, there we go. That's a horrible looking 3. Never mind, it's a 3. Estimate the interquartile range number of days off. So interquartile range is done in a similar way, just a little bit extra. All right, we're going to go from half of 21 is 10.5, so 10.5. We go across there. This is a quarter of 42 actually, I should really say. Won't let me draw that line, but we can see it goes to there and then it comes down here. All right, maybe draw that way. Don't know why this tool is rubbish on the computer. There we go. Okay, so you're supposed to go for 10.5 and then down, and then if we add on, or we go 3/4 of the way, if we added on 10.5 to 21, it would be 31.5. So we go from there, go across, and go down, and we'll see these rough numbers. Okay, so these aren't going to be exact numbers here. It's a little bit of a pain. So that would be 5, that would be 5.2, 5.4, 5.6, 5.8, 6. So each one of these little tiny squares, which you can barely see, is worth 0.2. So that's 5.4, and then that one is 1.2. Okay, so what we do, and I will zoom out and remember those numbers. I don't want to use that pen again. Whoops, that was zooming in like that. I'm going to use this pen and put 3 there because that's much nicer to use. I'm going to say that 5.4 minus the 1.2 is the interquartile range. That's what the interquartile range is. That's how we calculate it, because that's our upper quartile and that's our lower quartile values. Okay, so if we take away 1.2, we get 4.2. And that's the interquartile range number of days off, or whatever the thing is about. It might not be about days off, whatever. Okay, let's move over to the other side and see here. Obviously, in terms of the context of this particular question, you can't get 4.2 days off necessarily. Maybe you could actually. You get part of a day off, couldn't you? So we'll leave it at 4.2, but it might be okay to round to 4 whole number of days off if it asks for it in some more context. The graph shows the salaries of 80 fishermen. Estimate how many earn more than £35,000. That's the first thing that we need to do. So if we zoom into this one, I'll show you what you need to do again. Typical cumulative frequency question, this one. You go to where £35,000 is, you do the opposite way round. Now you're going up and then you're going across and you're finding out what that is. So it says how many earn more than, that's everything above that line you've just drawn. Okay, so there are 80 fishermen in the graph. You can see it's the top value, it tells us in the words, and you just got to work out what the scale is. So that's going to be 72, 74, 76, 78, 80, so there's going to be 6 fishermen there earning more than £35,000. Oh, it's not too bad of a 6. Then find the probability that the fisherman is paid under 15,000. So careful of this word here. Probability, answers need to be given as fractions, decimals or percentages, but probably fractions is easier because we know it's out of 80. So we know there's going to be 80 on the bottom of our fraction if it lets me draw it. There we go, and we're going to put a number on the top of that fraction, and that is going to be determined much the same way we did the other one. You're going to go from 15,000, you're going to go up, hit the curve, go across, be as accurate as you can, and find out the number of people that are under here. All right, so that's 0 up to 22, 24. So we're going to say that 24 out of 80 are, and I'll tell you what I'm going to do. I'm going to zoom out of that, and I'm going to use the other pen to fill in my answers. So there we go. So that was 6, and then that was 80, and then there was 24 underneath that line that we had drawn on the graph, right? Obviously don't rub out your workings, the lines that you draw on the graphs, because you will lose your marks, all right? I'm hoping that clears up some of the cumulative frequency questions, issues that any one of you might have had. There's not really much more to it than that. It's quite a nice grade 6 topic. I hope you enjoyed it. Thanks very much. Cheers. Take care. Bye-bye.